Divide proper fractions. How do we divide proper fractions? Proper fractions can easily be divided by simply multiplying them. After you follow a very specific process, however. When we have a usual fraction, we have our numerator over the denominator, and we would like to show this using a simple division symbol with this numerator over the denominator. You guys have heard this all before. We are going to keep, change, flip. What that means is we keep this first fraction exactly the same as the way that we see this. We change our division symbol to one of the multiplication symbols, and then we take this second fraction and we flip it upside down. Let's take a look at what that means. Our first fraction that we keep means that our numerator and our denominator stay exactly the same. Check. The change step means that we take that division symbol and we change it to something that means multiplication. In this instance, I'm going to use a dot. For that flip section, we take our denominator that's here on the bottom and we move it to the top of the fraction. Then we take the numerator that's on top and we flip that down to the bottom of the fraction. So here we flipped that numerator and that denominator over one another and we've traded them places. That's what that flip means. Just trade them places. We've done keep, change, and flip. Now that we've completed that step, we can see that this is just multiplication of proper fractions. And how do we multiply a proper fraction? That answer is straight across. So now what I'm doing here is I'm taking that numerator and I'm multiplying it by that denominator of that second fraction. And I'm putting all of that over my denominator and I'm multiplying that by the numerator of my second fraction. All right, let's try that out and see how that one works. Here, let's start by labeling our numerators and our denominators. We have 8 and 4 as our numerator, and we have 9s serving in the position of our denominator. What we're going to do when we want to divide proper fractions is to keep the first fraction exactly the same. Let's keep it exactly the same. Let's change that division symbol to a multiplication symbol. Okay, and then let's flip this second fraction denominator over numerator. That means my denominator is going to be on the top, my numerator is going to be on the bottom, and that is 9 over 4. All right, keep, change, flip. That's what that is doing there. How do we multiply fractions? Well, we multiply those fractions straight across. So now that gives me two problems that we're going to work with now, which is 8 times 9 over 9 times 4. Let's continue to work that out. 8 times 9 is 72. 9 times 4 is 36. And that is not a proper fraction, but this one is a little tricky because it simplifies down because both of these are divisible by 36. That gives me a value of 2 over 1. That 2 over 1 means I only need one part and I have 2, so that technically is 2 wholes. And we can just write a 2 to represent that. Now, there was so much going on in this problem. Let's make sure that we break this fully down, all right? Let's start back here at the top. We used our numerators as outlined in green here, and we put them through our rule, our keep, change, flip rule. Now, when we're flipping that here, we're flipping that, and that flip has a name. We are creating something, and it is called the reciprocal. R-E-C-I-P. The reciprocal. That means we just basically flip the fraction over what we would need if we multiplied it and wanted to get a value of 1. We've created a reciprocal. So the reciprocal of 4/9 is 9/4. All right, they are reciprocals of one another. That's what that flip portion means. Keep, change, flip. So we kept the first one. We changed that division to a multiplication, and we flipped that second fraction and made a reciprocal. Now that we're multiplying, we know that we can multiply. We know that we can multiply straight across, and that will give us 72 over 36. All right. Now, I could have gone through and shown the entire process for the greatest common factor, and I can absolutely do that practicing simplifying. If you need me to, just make sure to leave me a note on that. But 72 over 36 means that I need 36 pieces and I have 72. That can essentially jump down to 2 wholes from there. But if you didn't know that and you worked it all the way down and you started at dividing by 2, dividing by 2, dividing by 2, that is absolutely perfect as well. All right. So here we're given an example of how we have 2 proper fractions when multiplied give an improper fraction that we can simplify down to a whole number. All right, it's time for this check for understanding. I want you guys to dig into that to make sure that you understand it. Go ahead and pause the video here and give it your best effort. All right, let's try this check for understanding. Let's see if you were thinking what I was thinking. So the first thing I want to do is to highlight my numerators and my denominators. My numerators are on top, my denominators are on the bottom, and when my numerator is less than my denominator in value, then it is called a proper fraction. Here, I'm going to work these out. So, how do I work out 1/3 divided by 2/4? Well, I use my process of division to change it to multiplication because I love multiplication, and the easiest way to do that is to use keep, change, flip. So I'm going to keep my first fraction. I'm going to change my division to a multiplication, and here I'm going to use a little X there. And then I'm going to flip my second fraction and grab that reciprocal, which would be 4/2. Now that I can see this is a multiplication problem, I know how to multiply straight across, multiply proper fractions straight across, and that gives me a value of 4/6. Both of those are even numbers, so I know that I can simply divide by 2, divide by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So here is my answer, and that is another proper fraction. If you feel like you were successful in this lesson and that you can divide proper fractions, go ahead and check this box here. Happy learning!